Good morning and welcome back. Happy to meet you all again in this SPSS online course. And today in both the sessions, we are going to talk about various parametric tests that are available in SPSS. Before getting into the practical aspects, let me tell you something about the two kinds of statistics, what you can always do in a social science research. One is descriptive statistics. The other one is inferential statistics. The descriptive statistics just describe the state of affairs. It describes what is available, what is the data we have collected, what is summarized data we have collected, how we can summarize the whole picture of the data, what we have collected in terms of mean, median, mode, range, all those things. But there is yet another kind of statistics called inferential statistics. It is more useful when you talk about testing a hypothesis. So we all frame hypotheses in our social science or research, whether it is commerce, management, economics, or library science, banking, or any subject for the matter. So we frame a hypothesis. Hypothesis always framed as a null hypothesis. That is, there is no significant difference. There is no significant association. There is no significant correlation. So this is how we frame null hypothesis. And we want to conduct some test to finalize whether we are going to accept the hypothesis, accept this null hypothesis, or we are going to reject the null hypothesis. To do so, we undertake a lot of statistical tests that come under inferential statistics. Inferential statistics goes this way, in the sense, when you want to find out the internet use pattern of college students of India, it is not possible for us to go to each and every college of India, collect data from each and every student and find out their internet use habits. But instead, what we do as a researcher is, we select a group of colleges, and from those colleges, we select a group of students, we collect data, and whatever findings we derive from our sample study, we try to apply, we try to project, we try to correlate these findings to the entire population. The findings of the sample is going to be applied to the findings of the population. So that is what inferential statistics is all about. How to conduct these inferential statistics to test the hypothesis? There are two categories of statistical tests. One is parametric and another is non-parametric. Both are fine, but there are some conditions that are to be fulfilled by the data so that you can decide whether you want to conduct parametric or non-parametric. If you want to conduct a parametric test, and what are the conditions the data should fulfill? Basically, they say that the data should be in numbers. The data should be a numerical data. It should be a scale data. You can say it's an interval data, ratio data. It should be numbers. And secondly, the data should be, the data what you have collected should be normally distributed. The data should be normally distributed. Only when the data is normally distributed and the data is in numbers, you can go for parametric test. When your data is not in numbers, that means you have collected either ordinal data or nominal data, you can go for non-parametric test. Or the data you have collected is in numerical form, but this is not numerically normally distributed, then also you have to go for non-parametric test. The test like independent sample test, paired sample t-test, one-way ANOVA, two-way ANOVA, correlation, regression, all those tests are parametric tests. Chi-square test, Mann-Whitney-U test, Kruskal-Wallis test, Friedman test, Wilcoxon rank test, Spearman correlation test. These are all non-parametric tests. In today's sessions, we are going to discuss about both parametric and non-parametric tests if possible. Otherwise, we'll discuss about non-parametric tests tomorrow and parametric tests in detail in today's both the sessions. Fine. So let me go to SPSS. It asks whether you want to have a new data or you want to work on the old data. I select here open another file. In the recent file column, I select open another file, click on OK, and ask where is the file. So I go to desktop where I have kept all my files. SPSS online course. The folder final data set, I select t-test, then click open. Now I have opened a file by name 2 t-test, because I'm going to demonstrate 2 tests here. One is independent sample t-test and another is paired sample t-test. You can ask a question, sir, you told that there are 2 conditions for deciding whether we have to conduct parametric or non-parametric. One is the data should be in numbers, numeric, and second, the data should be normally distributed. So how to check whether a data is normally distributed or not? There are many ways. You can use histogram, or you can use skewness kurtosis values, or you can conduct a statistical test. In SPSS, we have a test called one sample KS test. This will help you to check whether the data what you have is normally distributed or not. For example, I go to analyze. In analyze, I go to non-parametric test. Then I go to one sample, analyze, non-parametric. Then I go to one sample. Okay, either you go this way or analyze, non-parametric, legacy. In legacy dialogues, you can have one sample case. You can go anywhere you like. So let me come to one sample case test. I want to check whether the data is normally distributed or not. For example, here I have some variables. For example, I want to conduct maybe on the variable errors. I want to check whether data is normally distributed or not. I have selected errors. I click this arrow to send the variable to the test variable list. I have to check whether data is normally distributed. So I selected normal, the OK. And you'll get the result here. You have to look at only one value, SIG two-tailed value. Only this one value you have to look at. If the SIG value, two-tailed value, if it is more than 0.05, if it is more than 0.05, it means that the data is normally distributed. The SIG value is less than 0.05, it means that the data is not normally distributed and you cannot conduct parametric test for this particular variable. Fine, good. So this is how you can check whether the data is normally distributed or not. So now I have got few values here. Let me go to view. I click value label. You get the answer like this. Okay. Let us conduct independent sample t-test. The hypothesis says that there is no significant difference between 2 levels of an independent variable on a dependent variable. What is the dependent variable here? You can see in the second column errors. The errors committed by the drivers. This is a dependent variable. What is the independent variable? The nighttime drivers and daytime drivers. So this driving has got 2 levels, only 2 levels, nighttime, daytime. So your independent variable is having 2 levels and it is a nominal data, and the dependent variable is errors. It is in numbers. This is in numerical form. Number of errors, number of mistakes committed by night driving drivers and day driving drivers. The hypothesis says that there is no significant difference between night drivers and day drivers in the number of errors they commit. This is our hypothesis. To check this, I have to go to two samples t-test because independent sample t-test. So go to analyze. In analyze, compare means. Go to analyze, compare means, independent samples t-test. Click on independent samples t-test. And here two boxes are there. One is a box where all the variables are listed, the left side. The other side we have test variables box and grouping variables box. Okay. And you have to send the dependent variable to the test variable. So what is our dependent variable? Errors. Select errors, send it to test variable. What is the grouping variable? Our independent variable is our grouping variable. What is our independent variable? Driving time, whether night time or daytime. I select driving, I send it to a grouping variable. Now we have to define the groups. We got two groups, nighttime, daytime. How I have coded this? Nighttime was coded as 1 and daytime was coded as 2. That's why I have given value labels. So define groups. I go to group 1 is 1, group 2 is 2, whatever number you assign. Continue. Okay. Now click on options. Okay, you can check the confidence interval. Let it be 95 by default. Click on continue and click on OK. So you get the result in the output window. You can see here t-test. Nighttime 646 respondents, daytime 8 respondents. The mean number of mistakes committed by night drivers is 8.67 and day drivers 5.75. It means that those who are driving in the night time make more mistakes than those who are driving in the daytime. And this column shows the standard deviation. Here you can see that the score is spread widely. There is too much of spread in the standard deviation in respect of day drivers than night drivers. The last column, standard error mean, shows the standard deviation of the sampling distribution. What is sampling distribution? You take the entire population, you divide them into many samples. For those samples, you find out the standard deviation, that is known as standard error mean. So this is the first group statistics table. And second table, independent samples test, it shows the result. First, it shows the result of Lebanese test for equality of variance. So there is a condition that the effect of independent variable on the dependent variable is having equal variance in respect of night drivers and day drivers. That means that there is an equal variance of night driving and day driving on the dependent variable. In that assumption, we conduct the independent sample test. This is another option, another condition that is to be fulfilled. You can check here, the SIG value is more than 0.05. If it is more than 0.05, it is assumed that equal variance are there. There is an equal variance. So equal variance assumption is met. If it is so, you have to look at the answer given in the first row here. Suppose if the SIG value is less than 0.05, then it means that the equal variance is not assumed. Then you have to look for the answer in the second row. This is what the whole thing is. But in our case, SIG value is more than 0.05. It means that equal variance is assumed. And so you have to see the column, first row, the answer in the first row. What does it say? T value is 4.560, degree of freedom 12. SIG is 0.001. Okay, it means that the SIG value is less than 0.05. If it is less than 0.05, it means that null hypothesis is rejected and the alternative hypothesis is accepted. That means there is a significant difference in the errors committed by night drivers and day drivers. So there is a significant difference. So what is mean difference? The mean difference is equal to 8.67 minus 5.75. That is a mean difference. What is standard error difference? It is the standard deviation of the population. Fine. So we have found out that there is significant difference between these two samples, these two groups of people. But as I told you, inferential statistics will help you to get the projected mean of the population also. So what would be the mean of the population? To know that, you come to the last part of this table, 95% confidence interval of the difference, lower upper. It means that the population mean, actually we have not taken the population, but if we conduct the study for the entire population, the population mean may lie between, it may come between 1.523 and 4.310. So this is what the independent sample t-test all about. Fine. So let us close this output window. Let me come to the next test. This is another condition where we need to conduct paired samples t-tests. We have to conduct paired samples t-tests. See, this is to be conducted when you have got something called a pre-test and post-test, before giving, after giving, before taking, after taking. So that kind of conditions you can go for paired sample t-test. For example, what is the mark scored by students before going to your tuition center, and what is the mark scored by them after joining and studying in a tuition center for some time, something like that. What is the blood pressure level of a set of patients before taking a particular tablet and after taking a particular tablet? So before treatment, after treatment. Here I got a data called AM PM. That means marks scored by 8 students when the test is conducted in the morning hours. The same 8 students, when they are taking the test in the afternoon, their scores. So I want to see whether there is significant difference between the marks scored by the students out of 10 when the test was conducted in the morning and the test was conducted in the afternoon. So I go for paired samples t-tests. To do so, you go to analyze. In analyze, come to compare means. In compare means, come to paired samples t-test. Click on go to analyze, compare means, paired samples t-test. Click on paired sample t-test. You'll get this screen. Here, you need to decide the samples, the two variables which are to be compared. What are the variables to be paired? So here, I select first my pair, morning. You click on this arrow, just come here under variable 1. And click on afternoon. Put this arrow, and this is displayed under variable 2. Now both the variables, marks in the morning, marks in the afternoon, they are taken. I'm going to pair these things. Click on options. Okay, let it be 95% confidence interval. Click on continue. You click on OK. You'll get the result of this paired sample t-test. You can see here, morning, afternoon. The mean marks scored by the students in the morning is 5.25 and the afternoon is 3.75. It means that the comparison of mean says that students are able to do better in the morning than when they write the exam in the afternoon. As far as standard deviation is concerned, the score is having a more spread in the morning than in the afternoon. And this is a standard error mean, that is standard deviation of the sampling distribution. Let us not worry about the second table which talks about correlation. Let us move on to the third table which tells whether there is a significant difference between the children taking exam in the morning and in the afternoon with respect of their marks. Here you can see mean value 1.500. It says that here you can see 5.25 minus 3.75 is equal to 1.5. The mean difference between morning test and afternoon test. And this is a standard deviation. That means you find out the marks scored by students in the morning and afternoon. You find out the difference. For the difference, you find out the standard deviation that is given here. And here you can come to the last portion of this table which talks about t value 2.646 and degree of freedom 7 and sig value is 0.033. It means that the sig value is less than 0.05. It means that the null hypothesis is rejected and alternative hypothesis accepted. That means that there is a significant difference between the marks scored by students in the morning and in the afternoon. Fine. And here you can see you are 95% confident that the population mean may lie between 0.159 and 2.841. And you can see how this is significant. So we have conducted a test on a small sample. Based on the findings of this sample, We are trying to project what would be the population mean. That is the beauty of inferential statistics. So till now we had seen what are the parametric tests, what are the non-parametric tests, and how to test for test of normality, how to test whether data is normally distributed or not. You go to analyze, non-parametric test, click on legacy dialogues, go to one sample case test, you conduct the test. If you're sure that the conditions are fulfilled, you can conduct the parametric test. Then you decide whether you want to conduct independent sample test or paired sample test. This test are conducted when your independent sample, the independent variables have only two levels: gender, male, female, or nativity, rural, urban, qualification, UG, PG. When your independent variable is having two levels, a nominal data, and your dependent variable is a numeric data, you can go for independent sample test or paired sample test. They are available under analyze, compare means. Under compare means you have got independent sample test and the paired sample test. I think you are clear with these two tests. These files, sample files, SPSS files will be given to you so that you can try working on these two files in the days to come. So thank you so much. We'll meet in the another session on parametric tests soon. Thank you so much.